Welcome back everyone, I'm Nick, this is Swiftful Thinking, and yes, this is my first video of 2022. I don't really have an excuse or a reason why I haven't been posting. Life just got crazy. I've been doing a lot of other side projects. But in my time away from YouTube, I've spent a ton of time writing code, specifically using Swift concurrency. And that's what we're going to learn in this playlist. This playlist is going to be everything that you need to know about Swift concurrency. For those of you who don't know, Swift concurrency was recently added to the Swift language. So before this, there were predominantly two main ways of writing asynchronous code in Swift. We used escaping closures and we used combine. And if you don't know either of those, I would recommend checking those out first before learning Swift concurrency. And I covered both of those on the continued learning playlist on my channel. Go check those out if you're interested and then come on back to this one. If you do have a basic understanding of how we used to write asynchronous code in Swift, it'll definitely help you learn here how we're gonna write it now. Now, admittedly, when Swift concurrency first came out, I was not sure if I was gonna be really using it that much. If you follow this channel, you know I love to use the Combine framework, and Combine is awesome and powerful in itself, but after using Swift concurrency for a couple months now, I can tell you with almost 100% confidence that this is by far the best way of writing asynchronous code in Swift. If you are a Swift developer, you need to be writing asynchronous code using async await as soon as possible. Using async await and actors is not only going to make you better as a developer, but it's going to make your app significantly better and more performant because as you guys are going to see, there's a ton of stuff that's just built into the language and to the compiler that will require us basically to code in a very specific way. And by writing our code in this way, we end up writing better code, more readable code, more efficient code, and safer code. As you're going to see, there's a lot of kind of safety nets built into the compiler to ensure that we are writing our code correctly. The first couple times that we're going to hit errors, it seems like annoying that the compiler is going to throw this at us, but really, as we're going to learn, this stuff is going to help us in the long run. It's going to make sure we are writing our code correctly and efficiently. Now, this playlist is going to be just like all the other bootcamp playlists on my channel. It is progressive. Each video is going to tackle a different topic. Topics are going to build on each other. More than other playlists, this playlist should definitely be watched in order because we're going to start with the simple stuff and we're going to work our way up to the harder stuff. In order to understand Swift concurrency, we also need a deep understanding of the Swift language. And so there are a couple videos in this playlist that are not technically new to Swift concurrency, but they're tackling things that are in the Swift language that I have not covered on this channel that we do need to know in order to really dive into Swift concurrency. So for example, one of the big things in Swift concurrency is the use of actors. But it's really hard to understand what an actor is if you don't understand the difference between a class and an actor. And it's really hard to understand that difference if you don't first understand the difference between a struct and a class. And so some of these things that we were just going to dive into in this playlist, I really hope will ultimately help you gain a better understanding of not just Swift concurrency, but the Swift language itself. And with that said, I will point out that the first 2 or 3 videos are a little bit slow in this playlist because we got to cover some basics first. But I promise you that if you stick with it, this playlist ramps up. It goes super easy to super hard in about 5 videos. So I'm very interested to hear your feedback as we get into it. All right, guys, that is it for me. I'm super excited to share this playlist with you guys. This was probably one of the harder, if not the hardest, playlist for me to make, because as you're going to see, there's so much technical details that we need to cover in order to get it deep understanding of Swift concurrency. And so this playlist ended up being not just learning Swift concurrency, but also diving into the Swift language, diving into just how we build apps in Swift. There's a whole lot of domain knowledge that I hope you guys enjoy.
React Native. Write JavaScript and React to build apps for iOS, Android, and the web from a single codebase. According to Atwood's law, any application that can be written in JavaScript will eventually be written in JavaScript. The first way JS developers tried to build mobile apps was by wrapping their native applications in a sandbox browser called a web view, using tools like Apache Cordova and Adobe PhoneGap. The philosophy is write once, run anywhere. This works, but it can be hard to make a website feel like a true native experience. React Native takes a different approach. It feels just like React DOM for the web, but instead of using HTML and the DOM as building blocks for the UI, it uses the native components that you would find on iOS and Android. The philosophy is learn once, write anywhere. You can't just take your existing React web app and upload it to the App Store, but you can use the React skills you already have to build a native app without ever having to touch Java or Objective-C. Instead, you import building block components like button, switch, scroll view, and the most fundamental of which is view. At runtime, it will use the true native component on the corresponding platform, like UI view, Android.view, or div on the web. It's like building 3 apps for the price of one, but in some cases, you may want a different visual experience based on the underlying OS. The platform module allows you to check which platform you're on and render different components accordingly. When it comes to visuals, there's no CSS in React Native. Instead, every core component takes a style prop that can be customized with a style sheet constructed from JavaScript. In development, it supports fast refresh, which means you can instantly see the changes you make to your code on any platform. You may also want to tap into native features like the device camera, push notifications, and geolocation. These concerns are handled by one of the most active open source communities on GitHub. There's open source packages for almost everything that can be installed with npm just like any other JavaScript project, and there's frameworks like Expo that build on top of React Native primitives to provide all the tooling required to ship your app to production. You can use React Native to build a complete mobile app or integrate it with existing iOS and Android projects. It's not an all or nothing solution. This has been React Native in 100 seconds. If you want to see more short videos like Go, a statically typed compiled language often described as C for the 21st century. It's a popular choice for high-performance server-side applications, and is the language that built tools like Docker, CockroachDB, and dgraph. It was created at Google in 2007 by legends who really know their stuff, like Ken Thompson, the inventor of the B and C programming languages. Version 1.0 was released as open source software in 2012. It was designed for simplicity and efficiency, and that's why we call it Go and not Golang. The source code is compiled down to machine code, which means it generally outperforms interpreted languages, but it's famous for its extremely fast compile times, made possible by innovations to dependency analysis. And even though it's a statically typed language, it performs type inference to deliver a syntax that is very concise and practical. It also has a package and module system, making it easy to import and export code between
right, welcome back everyone. We're gonna start off this playlist with probably the easiest video in the playlist. We're gonna cover do, try, catch, and throws. These are 4 keywords that are not new to Swift or Swift concurrency, but they're probably new to this channel. I have not really used them or covered them in detail on this channel, so I want to address these first before we start using them in every video going forward. These keywords have not come up much so far on my channel, but they are very important and used almost every single time we write asynchronous code using Swift concurrency. So many of you probably already know what these keywords do, but one thing that we're going to look at in this video, which is pretty interesting, is sort of like the evolution of Swift. Instead of just showing you guys how to use the keywords, we're going to talk a little bit about why we're using these keywords, because the why is almost more important here. The why helps us understand why we want to use these in Swift concurrency and going forward.
All right, welcome back everyone. It has been a while since I've made a video, so excuse me if I'm a bit rusty, but let's jump back in here. Let's open up Xcode. Let's start a new project. I'm gonna create a new Xcode project, and just like all the other bootcamp playlists, we are just gonna create a regular app here. I'm gonna call this one Swift Concurrency Bootcamp, and I'm not just like all the other bootcamp playlists, we are just going to create a regular app here. I'm going to call this one Swift Concurrency Bootcamp, and I'm not so concerned with the team or organization identifier or the bundle ID because we are not putting this into the App Store, but it is important to make sure that our interface is in SwiftUI and our language, of course, is Swift. What else would we be coding in, right guys? We are not going to use core data. We are not going to write tests. Maybe we'll write tests later, but I'm not going to do that for a while. So we'll leave those unchecked. Let's click next. Let's find a place to save this on your computer. Go ahead and click create. Once we are inside, I'm going to make this full screen. Let's get that simulator working and let's get coding. I'm going to switch my simulator up here to iPhone 13 just because it looks way better than the iPod Touch. Don't know why that is the Xcode default. And we're not going to use the content view, but we're going to create a new file for this video. So let's right click the navigator, create a new file. It'll be a SwiftUI view. Let's call this one do catch try throws bootcamp. Click create. And once you're inside there, let's click resume on the canvas one more time and get coding. And as I kind of pointed out earlier, what we're covering in this video is not actually new to async await, but we are covering keywords that we use in async await a lot. And on my channel, at least, I haven't covered them that often because we haven't really used a lot of these keywords at least until async await. So what we're going to cover in this video is do catch statements, as well as the try keyword and the throws keyword. And as you guys are going to see, all these keywords kind of work together. So that's why I'm putting them all into one big video here. And I'm going to move a little quickly here because a lot of the stuff we're going to do should not be new to you guys. So let's start by creating a view model for this view. So let's create a class. Let's call it do try catch throws bootcamp view model. Let's conform to observable object, and let's initialize one in our view with all into one big video here. And I'm going to move a little quickly here because a lot of the stuff we're going to do should not be new to you guys. So let's start by creating a view model for this view. So let's create a class. Let's call it a do try catch throws bootcamp view model. Let's conform to observable object, and let's initialize one in our view with an @state object private var VM, and we'll set it equal to do catch try throws bootcamp view model. I'm going to actually start calling my view models in this playlist rather than VM. I think it's just a little bit more clear for anyone who's just joining. And we're going to start super simple. So in the view model, let's create an @published var, let's call it text of type string, and I'll set it equal to starting text. I'm going to put that on the screen. So in here, we'll call view model dot text, and there shouldn't be an S here. Let's give this a quick frame with maybe a width of 300, a height of 300, and I'm going to give it a background color of color.blue. Just doing this because I just want to be able to see it on the simulator here. I don't really care what the view looks like in this video. And we're going to do a very simple .onTap gesture, and then we're going to perform a function. So in our view model here, let's create a func called fetch title, open close parentheses, open the brackets. Let's call this from our tap gesture. So in here, we'll call view model.fetch title. When we fetch a title, we want to update this text, but generally in your actual app, you're not going to really do your entire fetch request inside your view model. You probably have another class, a manager class or a data storage class or some sort of data loader, and that's where you're going to get your data from. So let's simulate that. Let's create another class. Let's call this one maybe do try catch throws bootcamp. Let's call it data manager app gesture. So in here we'll call video, and we're going to do a very simple .onTap gesture, and then we're going to perform a function. So in our view model here, let's create a func called fetch title, open close parentheses, open the brackets. Let's call this from our tap gesture. So in here, we'll call view model.fetch title. When we fetch a title, we want to update this text, but generally in your actual app, app, you're not going to really do your entire open close parentheses, open the brackets. Let's call this from our tap gesture. So in here, we'll call viewModel.fetchTitle. When we fetch a title, we want to update this text, but generally in your actual app, you're not going to really do your entire fetch request inside your view model. You probably have another class, a manager class or a data storage class or some sort of, data loader, and that's where you're going to get your data from. So let's simulate that. Let's create another class. Let's call this one maybe do try catch throws bootcamp. Let's call it data manager, and we'll open the brackets. And in here, we are going to have another function that says maybe get title, and this function will then maybe do try catch throws bootcamp. Let's call it data manager, and we'll open the brackets. And in here, we are going to have another function that says maybe get title, and this function will then return a string. So in here, let's just return new text. Why not? Let's get a reference to this manager inside our view model. So we'll say let manager equals do try catch throws bootcamp data manager. What a mouthful. Generally, of course, we're not going to initialize this in our view model. We're going to inject this. I do have a video on dependency injection on the channel if you want to check that one out. But now that we have this reference inside, of course, we're not going to initialize this in our view model. We're going to inject this. Let manager equals do try catch throws bootcamp data manager. What a mouthful. Generally, of course, we're not going to initialize this in our view model. We're going to inject this. I do have a video on dependency injection on the channel if you want to check that one out. But now that we have this reference inside here, we're going to call manager.getTitle. It's returning us a string, so we're going to say let new title equals that, and then we'll set self.text equal to the new title. Cool, I'm going to click resume on the canvas here. I'm going to press play and then tap on our box, and we got our new text. You guys probably already noticed that we have not used any of these keywords yet. Equal to the new title. Cool, I'm going to click resume on the canvas here. I'm going to press play and then tap on our box, and we got our new text. You guys probably already noticed that we have not used any of these keywords yet. And that's because we're going to build up to using these keywords, because I want to really explain to you guys why we use these keywords, not just how to use them. Once you understand why, it actually makes a lot more sense on why we then want to use these in Swift concurrency. So as a developer, this is great. This is all working perfectly. But the question is, what if we go to fetch our title, and maybe sometimes we don't actually get a string back. Maybe there was an error or a problem fetching that title. Well, how could we improve our code here? So let's simulate that error. We'll say maybe let is active of type bool. We'll set it equal to false. And just to simulate, so maybe when we call get title, we check if is active. And if active is true, we return the new text. If not, we'll do something else. So in here, we'll add if is active, and then we'll return our new text, and we'll say else. And if it is not active, let's then return nothing. So we're going to return nil. So we can improve this by then returning, making it optional. And then in our code down here, we could just very simply check if let new title equals new title, and then we can put our code in here. So again, I'm going to click play here. I'm going to click on this. And as you probably can see already, if I click and press on this, nothing is changing. And that's because is active is false. So we're returning nil, and then nothing's happening in our app. So already off the bat, we can see that there are limitations to just returning an optional, right? As a developer, we know that is returning optional because it failed to get the text. But if you're sharing this code, if other people are using this code, that's not very clear, and it might look like a bug in your application if maybe things are just not updating, right? So oftentimes, instead of just returning nil from a function, we want to take it a step further and maybe return an error instead. So an easy way to do that would be maybe from this function, instead of just returning a string, let's return maybe two pieces of data. We'll return a title as well as an error, and we'll make this optional, right? So now we can get a title and we can get an error. So if is active is true, let's return new text, and of course our error will be nil. And in our else, we're going to say nil for the title, and then we'll throw back an error. And in your actual app, you're going to want to use a real, probably a custom error, but we're just going to use a URL error here, and we're going to call .bad URL. It doesn't really matter what we're throwing back here. I just want to get this going. And the value we're getting back here is actually a tuple. And we can see that it has a title and also an error. So we could just name this maybe returned value, and we can check if let new title equals returned value dot title, and then we can say else if let error equals returned value dot error. So if we're getting that error back, we'll call self.text and put on the error.localized description just for a second. So I'm going to run this one more time, and I'm going to click on it, and you probably guessed we're getting back that error. This is good. This is a bit better in our code, right? Because now we have the ability to check for real values, and also check for errors. But this is kind of a hassle for us as developers because really we want to return a result here. Either this function should be successful or it should fail. It shouldn't really return us a title and an error, right? We should really probably only be getting one or the other. There's never really a use case where we're going to get both of these. So how can we improve on this even further? So I'm going to create another function here. So I'm going to create another function. I'm going to call it getTitle2, and this will return us a result, and I'll open the brackets. And as you're going to see here, a result is actually a generic type. So we need to provide the success type as well as the error type on failure. So we'll click fix. And the success type that we want to return back is a string, and the error type is just going to be a regular error. Now I'm going to do more or less the same code as we did here. So we'll say if is active, and if it's active, we're going to return success, and that's going to be a string. So we'll say return dot success, and we'll put in that new text. Then we'll say else, and we will return dot failure, and we'll put in our error. So I'm going to put my error back up here, put it into here. So now let's call getTitle2 from our code. So I'm going to actually comment this one out. So I'm going to / asterisk and down here I'm going to asterisk / do a multi-line comment, and then while I'm clicked right in front of this, I'm going to fold this up with the Option Command left arrow. That you could also go to the editor, go to code folding, and fold that up. I love folding code. It just looks so much cleaner. Now we're going to say let result equals manager.getTitle2, and we can see here that we're getting this result. If you've ever used Combine, and I've done that a lot on this channel, when we use Combine, a lot of times we call sync, and then we have a completion, and we switch on that completion. Usually it's either successful or it's failure. That is a result. That's the same thing that we're getting back here. It's either got a success case or a failure case. So we'll call it getTitle2, and then we want to switch on that result. So I'll say switch. So I'll say switch. And I'm going to switch on the result, and the case is .success. Let's say let new title, and this will be the title we get back, and we'll say self.text equals new title. And our other case, of course, is failure. We'll say let error. And finally, self.text is going to equal the error.localized description. All right, I'm going to give this just a different error, just so we get a different error message on the screen here. Let's click resume. I'm going to run this one more time, and we should get an error back on the screen again. And there it is. So already our code's a little bit better now, because this is if you're sharing this with other developers, or even if you're just coming back to this at a later date, it's much more obvious here. If we call this function, it's going to give us either a successful state or a failure state, right? It's no longer giving us back both, and then we have to kind of manage which one is which and look at both cases and look at all the data. Instead, now we just get back a result, and then we can either can identify very easily if it's a success or a failure. And you're probably thinking at this point, what on earth is this guy talking about? Because he told us we were going to learn do catch, try throws, and we haven't used any of that in this video. I know we haven't. I was a bit hesitant to even go down this route, but this video is not over, and we're going to jump into it right now. So we can actually basically improve on this even further, right? So right now, every time we call this function, we then have to switch on that result. But really, we know when we're calling this, we either are going to get back a success or a failure. So wouldn't it be nice if this function could just give us back one or the other, and rather than giving us back a result that we have to then check? And that's kind of where try and throws come in. So we're going to create another func here, and it's called getTitle3. You probably guessed it. And let's open the brackets. Now this function, we're going to go back to basics as we did in the first getTitle. We're just going to return a string. We're going to say if is active, and we'll return our new text. And then we'll say else. And the question is, if we can't actually get our data here, how can we then exit out of this function, right? Because we can't just return a string. We don't want to return a nil value. We don't want to return a blank string. Instead, we want to throw an error back out of this function. So the same way we passed an error back here, we called a failure state here and passed in an error. We just now want to just throw that error back out. And the way we do that is by marking a function as throws, meaning it can throw an error. And then in here, we can very simply throw an error. So I'll call URL error, and we will then use whatever error we are going with here. So the way to read this function is that it is a function called getTitle3 that tries to return us a string, but if it fails, it will throw us an error. So that's the beauty of throws, right? So instead of returning a result and then switching on the success and the failure, we can just return a string or throw an error. So let's use this in our code now. I'm going to come down here. I'm going to make another multi-line comment and fold this one up as well. Throw an error. So let's use this in our code now. I'm going to come down here. I'm going to make another multi-line comment and fold this one up as well. And let's do this one more time. We're going to say let new title equals manager dot get title 3. And you can see here when we call this that we can see that it throws, very explicit here, and it returns us a string. So the value that we're going to set here is actually going to be the string if it is successful. So I'll call get title 3 here. And now when we do this, we're going to get our first compiler error. It's kind of annoying the first time you hit these, but it's actually so handy because this is literally the compiler telling us how to write our code. We don't have to worry about it as developers if we're doing something wrong. So what this is saying is that this call can throw, but it is not marked with try. And the error is not handled. And that's actually exactly what is going on here. This function is a function that throws us errors, right? And we are going to try to get a string, and if we can't get it, we're going to get back that error. So the way to convey that in our code is to literally try to get the result of this function. So the question then becomes, if we are trying to get it, but we actually run into an error, if this actually throws us back an error, where are we going to catch that error? And you can see here that we're still getting another error here, that our errors thrown are not handled. And that's because we are going to try to run this, but if not, we need a place to catch those errors. So what we do is actually create a do catch statement. And you can see when you create a do catch, the first thing is inside the do is all of your tries, and then there is a catch where you're going to catch all of your errors. So I'm going to But if not, we need a place to catch those errors. So what we do is actually create a do catch statement. And you can see when you create a do catch, the first thing is inside the do is all of your tries, and then there is a catch where you're going to catch all of your errors. So I'm going to take this code, put it inside the do here, and then we can catch our errors. So in our catch block, we can then name the error if we want to give it a local name. So we'll say let error, and then in here we can do what we've done before. We'll say self.text equals the error.localized description. Inside this do, if we do get this new title, let's then just set that to the text. So we'll say self.text equals new title. Let's click resume. Let's do this one more time, and we should get that error back here. Awesome. And so now let's take a closer look at this do catch statement. So the do has a do block, and in your do block, you're going to have all of your try calls. These are all of your functions that can throw errors. Now, if there was multiple calls that we needed to try to make here, we can put a bunch of calls in this block. It's not limited to just one try, right? We can keep trying. But if any of these tries were to fail, we are immediately going to exit out of this do block and jump into the catch block. And I'll get further into that in a couple minutes. But for right now, we are going to try to get this title. If we are successful in getting this title, we're going to execute this line of code. But if we fail to get this title, this line of code will never execute. And instead, if we fail this, we're going to immediately jump into our catch block. And that comes down here. A really handy thing about these catch blocks is that if we want to just call it error, we actually don't need to even give it a local name here. So we can just, it can just imply that, and we can keep our function working as it is. All right, so we covered do, we covered catch, we covered try, we covered throws. And now I want to run you guys through a couple quick examples of using this try keyword because it is a little bit tricky. So let's create another function up here. Let's just call it getTitle4. In getTitle4, we're going to return, let's say, maybe a final text, just so it's a little bit different, so we know if this one is actually returning here. And let's come back down to our code, and what we're going to do is say let final title equals try manager.getTitle4. They're going to say self.text equals final title. So now we have two different try statements inside a single block. And before we run this, let's actually come back up here and make isActive true. So both of these should return values. So this one will be successful as well as this one. So let's run this one more time now. I'm going to click play on the canvas here, and we can see that final text is coming through. So we are running title 3, it's setting the new value, then we're running title 4, and then it's setting the new value as final text. And you can see that this is working perfectly. What I want to show you guys is that if one of these tries fails, the rest of the do block will not even execute. So in this getTitle3, let's actually just throw this error every time. So I'm just going to comment this out quickly. And we're just going to throw an error every single time we call. I'll getTitle3. So we know right now when we call getTitle3, it's going to throw an error. We know when we call getTitle4, it's going to be successful. But if I run this and I click on it, you're going to see that we get that error back even though getTitle4 would have been successful. And that's because, as I was saying, once you fail one of these try statements, you immediately go into the catch block. So if we fail this, we're never going to execute the rest of this. And that's really important. That leads us into the next use of try. You can actually make try optional. And when you make try optional, you're telling the compiler that you actually don't care about the error that's coming back. And instead of getting an error back, if you fail, you'll just set that value as nil. So if I take out this try and I hold the option button and click on new title, we can see that it's of type string. Because this is a hard try, we're going to get back that string. But if I make this try optional, hold the option button and click on new title, we can see that it is an optional string. So again, we're saying here, we don't really care about what error is coming back. If there is an error, we're just going to return nil. So the beauty of using the optional try is that you don't actually need to use it in a do catch because you're not actually going to throw any errors into the catch. So for a lot of simple cases, you could actually just take these. I'm going to copy this and let's actually remove the question mark here. I'm going to put it up here. So we can say let new title equals try this, and we'll say maybe if let new title equals new title, self.text equals new title. So if I comment this out here and I go to run this, let's see, get title 3 is throwing us an error. So even though it's throwing us an error, we are not actually doing anything with the error, so this will just be optional. When I click this, nothing happens. If I uncomment this code, put this back in here, we can see that it's now working again. So the biggest benefit of the optional try is that firstly, you don't need to do catch block, and then it saves you a bit of time as the developer if you don't really care about that error anyway. Sometimes if you're using like third-party APIs and they're throwing you back errors, but you're not going to actually display that to the user, maybe you don't really care about the errors that are being thrown back. But before we move on, I want to actually show you guys using the optional try in the do catch block. So I'm going to comment this out up here. We're going to make this one optional. We're going to say if let new title equals new title, and we'll put this inside this if let statement. I'm going to make get title 3 fail every single time, just like we had before. So let's comment this back out. Let's throw that error every time. So now we know this will throw an error, but this one will not. And if I run this again and I click on it, you're going to see that final text is coming through. So even though get title 3 is throwing an error now, we are not coming into this catch block. So before we threw an error, we did not run any of this code and we just jumped into the catch block. But here, because we marked this try as optional, we're not actually going to throw the error. We're not going to actually catch that error. So even though it's technically throwing an error from the function up here, we marked it as optional, so we're not actually going to throw it out of the do block. I hope that is clear. On this same note, you can also explicitly unwrap a try. So I could do something like this, and then the new title will be a string 100% of the time. We don't need to unwrap it at all. Now again, explicit unwraps are super dangerous. I do not use them in code. I do not recommend using them, but I wanted to show you guys that they are there. I'm going to comment that back out. And I think I'm going to wrap up this video there. Decently long video here. We didn't cover anything related to async await, but most of our asynchronous code and our asynchronous functions are going to actually be functions that throw errors. So this syntax is going to be really, really common in async await. And when you're using throws, you're almost always using do catch statements. So this code is going to be super common in all the videos going forward, and that's why I wanted to cover this first. I hope that does clear it up for some of you because I haven't covered this on my channel before. Honestly, we don't really use these keywords very much outside of async await. At least I haven't very often on this channel. So there it is. There you have it. We covered it. Do catch, try, throws, some really powerful stuff here. And in the next video, I think it might be time to actually jump into async await. Thank you guys for watching. As always, I'm Nick. This is Swiftful Thinking, and I'll see you in the next video.
Bravo's code.
I don't think I'll ever get this many
All right, we are on video number 3 of a Swift concurrency playlist, and we have not yet written any Swift concurrency code. We have not used async and await, so it's probably time to start doing that. So in this video, we're going to download an image using async and await. We're going to just jump right in, we're going to download the image, and then the next couple of videos, we're going to really take a look at the word async, the word await, and some other keywords, of course.
All right, welcome back everyone. I'm in our Xcode project here. Let's right click the navigator, create a new file, and this will be a SwiftUI view. Let's call this one download image async. Click create, and let's get code here. Let's SwiftUI view. Let's call this one download image async. Click create, and let's get coding. What we're going to do in this video is basically jump right into the world of async await, but we're going to do that by first downloading an image using escape enclosures and using combine, and then we're going to do the same thing using async await. I think for me at least, seeing the old and original ways to do it versus the new way makes it much more clear in my mind what pieces of code are the same, what pieces are different, and maybe why we are doing this the new way. So that's what we're going to do. If you don't want the recap of the escape enclosures and stuff, I would say go ahead and fast forward this video, probably 3/4 through it. But if not, it's probably going to be a great recap. It's a great recap for myself, so I assume it's a great recap for some of you guys as well. Again, I'm calling this download image async because in the SwiftUI continued learning playlist, I did a download image with escape enclosures and then with combine. So let's get set up here. I'm going to create a view model for this view. We'll call it download image async view model. Conform to observable object. Let's create our state object, private var view model, and we'll set it equal to a download image async view model. Our view model will hold a reference to a published variable called image of type UI image, and we'll set it equal to nil to start. We're going to create a function here that says maybe fetch image, and for 1 second, let's just set it as a system image for now. So we'll say self.image equals UI image. System name, let's just maybe do heart.fill, and let's set up our view. It's going to be a simple Z stack. We're going to say if let image equals view model.image, and then we'll put that image on the screen. So we're going to say image from a UI image, pass in our image. Let's make it resizable, let's make it scaled to fit, and give it a quick little frame of maybe 250. By 250. Cool stuff, I know. When this VStack appears, we will then call view model dot fetch image. Let's click resume. Let's get this image onto our canvas here. Cool. Not very high quality heart there, but I do love you guys. Let's keep moving here. And just like in the last video, oftentimes you're not going to actually do your fetching from the view model. You're going to have another outside class, a data store, an image loader, a downloader, manager. Let's simulate that by creating another class, and we're going to call this one download image async. Let's call it image loader. Why not? And in here we're going to have a function to then obviously fetch an image. So we'll say func, let's call it download with escaping, because we're going to use an escaping closure in this one, and we'll open the brackets. We're going to call a URL session.shared.data. We're going to look at all of these completions here, and this is kind of the whole gist of this video here. So Apple provides us with the URL session API, and in here we can see that there's a whole bunch of different ways to initialize one. So at the top we have these completion handlers. So that is your escaping closure. That's the first method that we're going to check out here, and we can see that even just the syntax in here, this completion handler, looks a bit different than some of these other ones. After we do this first completion handler method, we're going to then check out the data task publisher. If you've been following my channel, we've done a lot of Combine, and that's what these are for. So these are returning us back publishers that we can use in that Combine pipeline. The final thing we're going to check out is actually what's grayed out down here, and we can see the async keyword down here. And these, you can see, have a slightly different syntax, but notably that they throw and then return data. So throws, one of those keywords that we used in the last video. Obviously async is a new keyword that we're going to check out at the end of this one. But before we get to this, let's look at how we are doing this without the async keyword. So how we do it with just a regular completion handler here. So I'm going to look for this one with a URL and a completion handler. We got to pass in a URL. So let's create one up at the top here. Say let URL equals URL from a string. And I don't have the string yet. I'm just going to explicitly unwrap it. I know that's not safe, but we're going to do it for this video. All right, and the URL we're going to use is actually from pixum.photos URL from a string, and I don't have the string yet. I'm just going to explicitly unwrap it. I know that's not safe, but we're going to do it for this video. All right, and the URL we're going to use is actually from pixum.photos. It's a free online API. I'm just going to take maybe this one just to get a square random image. Every time you hit this API, you just get like a random image back. Super convenient. Let's put that in here and let's then pass in our URL. And now we get this completion handler. And this completion handler is what we really want to point out in this method. When we use these escape enclosures, we have these handlers. handlers, and then we have to kick back these handlers outside of this function as well. We're going to do that in 1 second. So let's click enter here. This will be our returned data, our returned response, our returned error. Just to iterate to you guys one more time, this line of code executes as soon as we call the function. This block of code executes these handlers outside of this function as well. We're going to do that in 1 second. So let's click enter here. This will be our returned data, our returned response, our returned error. Just to iterate to you guys one more time, this line of code executes as soon as we call the function. This block of code executes when the data comes back from the server. So there could be a bit of time between this, and that's why we have these closures, right? Because it's asynchronous code here. To kick off a data task, you just have to call resume to make it start, and then let's just handle this response. Firstly, let's check for data. So we'll say guard, we'll say let data equals data. Let's also try to convert that data to an image. We'll say let image equals UI image from data. Let's also check that the response is good, but this response is a URL response, and we really want to check if it's a HTTP URL response. So we'll say let response equals response as an HTTP URL response, and then inside that response we can then check the status code. So we'll say image from data. Let's also check that the response is good, but this response is a URL response, and we really want to check if it's a HTTP URL response. So we'll say let response equals response as an HTTP URL response, and then inside that response we can then check the status code. So we'll say response.status code is greater than or equal to 200, and with a double ampersand, response.status code is less than 300. This is just your general HTTP response codes. You can Google that. It's not Swift specific. And then we'll say else. So if we fail this guard statement, we then want to close out of this function. So here we'll just return for a second. If we do get this image, we then obviously want to kick back that image back to the application. So how do we do that with escape enclosures? Well, we pass our completion handler outside of the function. So up here we'll call completion handler, and that will be of type, and it's going to be a function that returns void. Another way of writing void is just open and close the parentheses. That's probably more common, so I'll leave it like that. But inside this completion handler, what do we actually want to send back here? So we want to send back the image, of course, and maybe we want to maybe an optional error if there was a problem. So here we'll say image of type UI image. We'll make it optional in case we can't get it, as well as error of type error. We're going to get a quick error here in these completion handlers. As you can see, function types cannot have argument labels. Basically, we just need to add the underscore here for the public name, and the image will be the local name. So now we have our completion handler, and we can call this completion handler whenever we want inside this function. So if we are getting an error here, we're going to call our completion handler, and the image, of course, will be nil, and then we can maybe pass back our error. It's the error that's coming from here. But if it is successful, we can then call our completion handler. We can pass in our image, and the error will then be nil. We get one final error that, of course, escape enclosure captures non-escaping parameter. So basically, this completion handler can be used inside this function, but it can't be used outside the function. So how do we escape back outside? We mark it as at escaping. I have a whole video on at escaping, and if it is confusing to you, but this should be the familiar part of this video, because in a second we're going to get to the new stuff. So let's call this function from our code now. So down in our view model, let's get a reference to our image loader. So we'll say let maybe loader equals download image async image loader. And then in our function, we're going to call that new escaping closure. So we're going to call loader dot download with escaping. We get our completion handler, and you can see this image error is exactly what we put up here. We're going to click enter on that, and then we're going to get our stuff back. Now for this video, I don't really care about dealing with the errors, so let's just check if we get that image. We'll say if let image equals image, and if we get the image, let's update this image. We'll say self.image equals image. Now we are good developers and we know that this is asynchronous code, and by calling self here we are creating that strong reference to this class. So we really want to keep that a weak reference, and then we can make the self basically optional. Have yet another video on weak self if it is confusing you still, but that's not what we're worrying about here. So let's resume this. Let's play this, and bang. We got our image already. That was super fast. Running this on the canvas, we can't see any errors, but play this, and bang. We got our image already. That was super fast. Running this on the canvas, we can't see any errors, but having done this many times in my life, I do know that we should probably be getting an error here. I would ask you guys to pause this video and try to figure out what the error might be. So when this loads, you guys should see, I think the image will still load, but we're gonna get this purple error. Publishing changes from the background thread is not allowed. That is the error. And that's because when we call these URL sessions, they actually run on a background thread, and we need to switch back to the main thread before updating our UI. So in here, we can then first switch back onto the main thread. I actually noticed that this image is optional, so we don't even need to really unwrap it here. We could have just left it kind of like this, and we can actually just dispatch queue.main, meaning the main thread, async, and then we are back on the main thread. So now we can run this and not get that error in our code. Awesome. Awesome. So this is how this is kind of the first iteration of asynchronous code in Swift. We use escaping closures. We use these completion handlers. And we kick them back out. Now we're going to download. Awesome. So this is how this is kind of the first iteration of asynchronous code in Swift. We use escaping closures. We use these completion handlers, and we kick them back out. Now we're going to download. Using two other URL sessions in this video. All three methods are going to return us back data response error, and we're going to handle the response the exact same way. So because of that, I don't want to focus on rewriting this code. Let's extract it to a function. So up here, I'm going to create a func, call it handle response. Let's see here. We need to pass in the data of type, I think it's optional data, as well as response of type URL response. Let's take this guard statement here, paste it up here. Let's make this function return the. Let's see here. We need to pass in the data of type, I think it's optional data, as well as response of type URL response. Let's take this guard statement here, paste it up here. Let's make this function return the image. So this function should return a UI image. And just for simplicity's sake, we'll make this one optional. So if we have the error, we're just going to return nil. So down here, this function return the image. So this function should return a UI image. And just for simplicity's sake, we'll make this one optional. So if we have the error, we're just going to return nil. So down here in the code, let's just say maybe let image equals handle should type URL response. Let's take this guard statement here, paste it up here. Let's make this function return the image. So this function should return a UI image. And just for simplicity's sake, we'll make this one optional. So if we have the error, we're just going to return nil. So down here in the code, let's just say maybe let image equals handle response with the data, the response, and then we can call completion handler on the image and the error if there was an error. So I will delete this. Completion handler on the image, return nil. So down here in the code, let's just say maybe let image equals handle response with the data, the response, and then we can call completion handler on the image and the error if there was an error. So I will delete this. Call to method handle response requires explicit use of self yet again, so that's creating that strong reference. Let's keep that weak. And now we are writing good code. Again, this line of code is not what we're worrying about in this function, but the rest of it is dealing with these closures and these closures. This is basically what we want to avoid by using our new handy dandy Swift concurrency stuff. Before we get into Swift concurrency, I want to run you guys through what this looks like using Combine. So let's create another func here called a download with Combine. We're going to call URL session shared.data task. Look for the publisher for the URL, and we'll pass in our URL here. We are then going to map that response, and we can see that the data we're getting back here, data and response. So that is the same keywords that we have in this function here. I did that. I already checked it before we made this video. So we'll call handle response, and it's implied, so we can just keep it like that, nice and clean. We then want to erase this to any publisher so that this function can return us any publisher. And we don't have access to any publisher because we have not yet import the Combine framework. Any publisher. Just like the result in the last video, any publisher is generic. So you need to declare the type and the error type. So the error is just going to be a regular error. The success will be a UI image. We'll just keep it optional for now. We're going to get one quick error that basically the error coming back is a URL error, and the error that we marked here is a regular error. So we can just map the error from a URL error to a regular error, which is the error itself. They conform to the same protocols, so we'll just keep it like that. Again, that's not what we're focused on here. Let's call this from our code. So coming down here, instead of download with escaping, I'll comment that out. Let's call loader.download with combine. And we get that nice any publisher back. This, we want to then sync the value. We get the completion, which we're not going to worry about. I'm just going to leave that blank, and this will be our returned image. And then in here, we're going to do the same thing that we did here. So we want to switch back onto the main thread and set up our image. Let's also keep our reference weak. Finally, we want to store this somewhere, so we'll call store our cancelables. We need a set. So up here, let's create our var cancelables equal a set of any cancelable, and let's store them in that set. I'm going to build and run this one more time. Everything is working perfectly. This is actually not the combine way to switch back onto the main thread. So one of the key differences from the escape enclosures to the combine is that we can use these pipelines. So we can then actually just receive values on the dispatch queue.main. We don't need any options, so I will just delete them. And then we don't actually need that dispatch queue here. And we can build and run. We'll see that we don't get that purple error because we are still receiving on the main thread. So this is kind of what I wanted to point out here in this video is like, this is one way of doing it and this is another way of doing it. Both of these are valid ways to do it. Next is using async await, which is probably a sleeker, more elegant, and probably even more efficient way to write this code. And towards the end of this video, I'm going to start highlighting some of the major differences. So now that we did escape enclosures, we did combine, I think it is time to actually jump into async await. And I promise the rest of this playlist will actually be async await stuff. This is kind of just the intro. Let's create a func called download with async. Open close parentheses, open the brackets. We're going to call URL session shared.data task. And we're going to look for the ones that are actually grayed out right now. And the reason they're grayed out, they have this async keyword here. And we can see it at the bottom.
Guys, this stuff is a little bit more heavy on the brain here. So I'm actually gonna take a break here because it's like 2 a.m. and the other stuff was okay, and it was nice to see things happening, like getting exposed to stuff. But I think I'm getting to that level of tiredness point where I can't quite focus, even though focus. I can't even focus enough to take in the fact that it's going on the screen. Like that's one of the points of watching this, just like get exposed. But I don't even feel like I'm getting exposed at the moment. So yeah, I'm gonna take a break actually here. I can talk at the moment because I'm really close to my computer, and yeah, I'm just kind of whispering, or like a low voice, obviously. Oh man. I think that was actually a pretty good session though. Also, I know my girlfriend is definitely very asleep because she is snoozing. She's hit the snooze button. I need to hit the snooze button now though. Pop. All right, guys. Thanks for joining me tonight. Appreciate it. We are progressing in our power of Swift in our learning. We are progressing. We're getting there. We are making it to our 100K a year position. Even if I can get a 50K a year position, better than nothing. Or we start making money with our apps on the App Store. We need to cover a lot more topics, I think. So we need to get more proficient. We need to get more efficient at covering topics. So tomorrow, Sunday, is generally my day off at the moment, so I won't be on tomorrow. But I'll be back on Monday night. I think. I think I might be setting up Sunday and Tuesday as my nights off. Generally Sunday will be my night off of streaming, at least, and Tuesday this week I can't, so I might just set it up as Sunday and Tuesday, but we'll see. Maybe it's better to like split them up a little bit more. Perhaps Wednesday or Thursday is better, and Sunday. We'll see how we go. If you stuck with me this long, if you would be so kind, I definitely wouldn't mind if you guys subscribed. That'd be awesome. Definitely helps me get makes my way to 1,000 subscribers and a official YouTube partner, and send all that ad money that they're taking right now back to me. That'd be awesome. And if you would like to, I have set up a Discord. It's in my pinned comment, the link. You can join, and I just started it, so I'm adding more stuff, more sections, and more channels, and I'm gonna have some updates on what I'm working on, the apps I'm working on. Hopefully we can make a community in there, and we can ask people questions, get some answers. I was not directly referencing the Little Mermaid there, but it sounded like it was. Oh my god. Yeah. So yeah, trying to make a community in there. Be really awesome if we could do that. And I think that's it for my shameless plugs for today. I'll thank you so much, guys, for joining. It was awesome to hang out. I know I wasn't chatting much tonight. But yeah, next time we'll try and get the mic on. Definitely. So I'll see you all on Monday night. Bye. Have a good rest of your day, guys. See ya. Good night. I'm waving with like this. Why? Bye. Bye, Lisa.